In this question, a fictional scientist is carrying out a fictional decomposition reaction of Rx2, which we can see in our chemical equation here. Similarly to the previous skill, we're given a graph. This one measures how the concentration of Rx2 varies over time as the reaction progresses and plots the straight line graph of 1 over the concentration of Rx2 against T. So we can see that on our y-axis here and our x-axis here. So our goal is to figure out what is the integrated rate law for this reaction, what's the differential rate law, what's the order, and then to calculate the rate constant using the slope. So first let's figure out which rate law this is. We've got 1 over the concentration of Rx2 on our y-axis. So let's head to our reference sheet. Here's our rate law that involves 1 over the concentration of our reactant. That is the integrated rate law second order. So it's our second order rate law, and it's 1 over the concentration at time t is equal to 1 over the concentration at time 0 at the beginning plus kt. So that's going to be this one here. So based on the fact that this is a straight line, we know this is the integrated rate law. And because we know from the reference sheet that is the second order integrated rate law, we know it's a second order equation. And so we can figure out our differential rate law for this reaction is going to be rate is equal to K multiplied by the concentration of our reactant, Rx2, to the power of the order, which is 2. So that's going to be our differential rate law. Let's find that in here. There it is. Okay, so now we're trying to figure out the slope of our line, figure out what the slope represents, and use that to find the rate constant K. So, same as in the last skill, here's our integrated rate law equation. We need to map that onto y equals mx plus b. So the y is the 1 over Rx2 concentration at any time. The t is going to be our x. So the m is going to be positive k, where k is the rate constant. The b is going to be 1 over the concentration of Rx2 at the beginning. So our slope is equal to our rate constant. So down here, what does the slope of the straight line represent? It represents k, the rate constant. So to find the rate constant, all we need to do is find the slope of this line. So to do that, I'm going to draw a triangle on here on my graph. I'm looking at my change in y. My y value ends up here, which is at 0.17. So that's my final y. And I'm subtracting my initial y, which is 0.06. That gets me a change in y of 0.11. And my unit for that is 1 over m. For x-axis, my change in x, it ends up at 5. And I'm subtracting what I start at, which is 0. So 5 minus 0 is just 5, and that's in units of seconds. Okay, so for my slope, that's going to be my change in y divided by my change in x. My change in y is positive 0.11. My change in x is 5. So putting that into my calculator, I get a slope of 0.0220. So we can fill that in for our rate constant here. Awesome, that's correct. Lastly, to find our unit for our rate constant, K, remember that changes based on what the order of our reaction is. So we can figure that out either by rearranging our integrated rate law or differential rate law for K equals, and then plugging in our units for each thing, or we can just use the units for our slope. So for our change in y, we had 1 over m divided by our change in x, which was seconds. So that's the same as 1 over ms, so 1 over molar seconds. So my unit is going to be per molar seconds. So the first part of this skill is pretty much identical to the previous skill, where we're just identifying, based on the graph given, what is our integrated rate law for this reaction, what's the order, and what's the differential rate law. Then we're needing to actually calculate the slope and use that with what the slope represents to find the rate constant for this reaction.